Hey everyone, and in this video we will be talking about 1.1 change in tandem. This is the first video in our series of precalculus on this channel. Okay, so let's get started. So firstly, we will be talking about functions and the definition of a function. So what is a function? So a function is basically like a mathematical relation that takes input values and maps them to output values. So for example, if we have some input space right here, so this is like the domain, and then we have some output space, so like the range is right here. And then if we have like an element in the domain, call it x, and the element in the range, just call it y, then a function will map x to y. Okay. All right, so that's what a def function is. So then let's talk about function notation. Okay, so function notation looks like this. So this is read as f of x. And so basically, whatever's inside the parentheses is your input. This is the input, or like the independent variable. And then the function spits out the output. So f is the output, or the dependent variable. Okay, so let's do an example. So let's say we have some function g of x, where g is the area of a table, and then x is the length of the table. So then the input, or the independent variable, will just be x, right, which is the length of the pool, or not the pool, the table, sorry. And then the dependent variable will just be g, which is the area of the table. Okay, so hopefully this should give you an idea of what a function is. All right, so now let's get into increasing and decreasing functions. So let's start with increasing functions. So an increasing function, so the formal definition of an increasing function is for all a and b in the real numbers, if a is less than b, then f of a is going to be less than f of b. Right, so that's the definition of an increasing function. So to make this a little bit more clear, let's draw a picture. So if we have a graph, and let's just say like the function looks something like this, right? So if this is our choice of a, and this is our choice of b, so then f of a is like roughly right there, right? And then f of b is like about right there. And so now we can see that if a is less than b, for it to be an increasing function, f of a has to be less than f of b. So this function would be increasing. Okay. So then now decreasing functions is a similar argument. So for decreasing functions, the formal definition is for all a and b in the real numbers, right? If a is less than b. So now the key difference is f of a is greater than f of b, right? And so if we draw a graph again, it would look something like this. So that's like a decreasing function, right? So y equals f of x, right? So if we choose this to be a and then we choose this to be b, so then f of a is like right about there, and then f of b is right about there. So now we can see, oops. So now we can see that when a is less than b, so now f of a is greater than f of b. And that's what characterizes a decreasing function. Okay, good. So now let's talk about some key features of functions. So to start, we start with 0. So what is a 0? So a 0 is where the graph intersects the x-axis, right? So some other terms for 0 are like x-intercept, a solution, or a root, right? All these names mean the same thing. And the definition is it's where the graph intersects the x-axis. Right? So, and then the next term, next key feature is y-intercept, right? So, like how the 0 was where the graph intersected the x-axis, this is where the graph intersects the y-axis. Okay, so it's where graph intersects y-axis. And a key thing, lack for a better term, is that a graph can only have, or like a function can have maximum one y-intercept, and it can have there's no restriction on how many x-intercepts, or like zeros can have. But a graph can only have one y-intercept. So if a graph has more than one y-intercept, it is not a function. All right. So if we visualize this, x, y. So if we have some graph, say like something that looks like that, right? So this right here would be the y-intercept because it's intersecting the y-axis at this point. And then the x-intercept, or the zeros, would be right here. Okay? All right, good. And so then the another key feature is concavity, right? So concavity, basically if the graph opens up or down. Okay. Concavity. So concave up means graph opens up. Okay. And then concave down means that the graph opens down. Okay. So if we draw a picture again, it would look something like this. So if we have some function, say like that. So we can see like from here to the point, it's opening down. It's like a downward curving bowl, right? So this would be concave down right here. And then from here to the infinity, it's like opening up. It's like a upwards facing bowl. So it'd be concave up. Okay. And so this point is where the function changes concavity, right? It goes from concave down to concave up. And so that point is called the point of inflection. Okay. And so the inflection point is really like the graph changes concavity. So if it goes from concave down to concave up, or concave down, or concave up to concave down. All right. Okay, good. So that concludes this lecture in our pre-calculus series on this channel. See you next time.